going to teach you the beginnings of arrays, and what I want to point out, which I never managed to in the introduction, is that when we write our programs, this is important. There is not always one right answer. There are loads of different ways of doing the same thing. There may be an efficient way, or the most efficient way of doing something, but essentially, if we get our program to work, no matter how we've done it, that would be a right answer. It might not be the most efficient, and that's how we're going to start this section. We're going to look at something that is not very efficient and not necessarily the best way of doing it, but it is a correct way of doing something. Also, during this series of videos, we need to learn a little bit about robustness of programs. That is making sure that the user who is using our program cannot deliberately crash the program. Because if they can crash the program, then they may have a back door in, and we don't want that to happen. We don't want to let anybody see our code. We don't want anybody to alter our code. So we need to make it as robust, as strong as possible, so it cannot be broken by the user. And with that as well, I'm going to talk about some programming techniques that we can use to help us solve our problems, maybe make the program a little bit more efficient, but definitely make it more robust. So we've got a lot to learn throughout this period of videos. So I'm going to start off with an introduction or go back over some of the things that we've done in the past. So I've got Python up on the screen, ready to go. We've seen things called data types. So I'm just going to mark out a few comments, data types, so that we can see and list things. You don't need to type the red comments if you don't want to, but they are useful when you want to revise your work. Now, the data types that we've been using at the moment are simple ones. Simple or basic. They appear in every programming language there is of this nature, not necessarily fourth generation or first or even second, but certainly in third generation languages we have some simple basic data types. And you've met these three. You've met the number data type, and you've met the string data type, and you've met the Boolean data type. And I will talk about these a little bit more in a minute. But these are very simple, basic, because they take just one value. That's why they're simple, not because they're easy, because they just take one value. And they also break down into other parts. So numbers break down into integers and reals, because we've got two different kinds of numbers. We've got whole numbers, which are integers, and we've got reals, which you probably know as decimals. String, in Python there is only a string available to you, but in other languages you may also have a data type called character. The difference between the two is that a string is basically several letters strung together. Anything that you can type on the keyboard, but more than one. Whereas a character is just one letter or symbol. You can't have more than one. But Python doesn't support this data type. It only supports strings. Other languages such as C++ or JavaScript or whatever do support characters. And Booleans can only contain the value true or false, sometimes 1 or 0. So let's give some examples of what they look like. So in the number we can have integers, so an integer would be like 26, and a real would be something like 26.5. A string would be like hello, but strings are enclosed in quotes. And a character would be a single letter, such as H, and they are normally enclosed in single quotes. Now you can use both single and double quotes in Python, there is no distinguishing factor between them. However, in languages such as Python, Pascal or Delphi, yeah, there's a big distinction. All strings must be in double quotes, and all characters must be in single quotes. Booleans can either be true or false, and in Python they need to be preceded with a capital T and a capital F. Some languages you can use lowercase, but not in Python. Or sometimes you can use a 1 for true and a 0 for false. They are our simple data types, basic, because they take only one value. Now let's go back to the dice program that we did for our project. If you can imagine that I rolled 6 dice and wanted to keep their values and store their values, I could use variables. So if I rolled a dice once, I'm going to call this variable number 1, and I got the value 1. And if I rolled a dice again, I would need another variable num2. That might be 4. Let's make that neat. And then I could roll it again and get the third number would be equal to, I don't know, 3. Then the fourth one would be equal to 1 again. And the fifth one, I'm just making these up. You can do what you like. But notice the variables. There's no spaces between the letters and the number on the end, num1. And we can't start off with 1 num. That would be illegal. So it's got to be this way around. Let's just put another 1. Let's do num6 for my 6th roll. Oops. Let's make that 2. So every time I roll a dice, I could assign it to a variable. And that would be absolutely great. Unfortunately, it's not very efficient and not very easy to play with. We need a better data type to do that with. And that data type, you've guessed it, is called an array. So what I like to do, and it's not necessary, when I name it, I put the word array at the end. So instead of having num1, num2, num3, so on, I just say num array. And if I set it equal to, and then in square brackets, I can put all of these values. 1, 4, 3, 1, 1, 2. And that is absolutely 100% fine. Now, this is not a simple data type. This is a compound data type. And sometimes they're called complex data types because they hold more than one single value. And you can see that this one holds 6. And I could just keep going. I could put more in there if I wanted to. I don't need to be limited by the amount of numbers that I need. The problem is that if I roll the dice again, I've got to keep coming up with new variable names. Now, if you can imagine rolling the dice 1,000 times, I would have to write 1,000 variable names, num1 to num1001. But if I used an array, I only need to have one variable name, and inside the square brackets, I could put all my 1,000 dice rolls. Now, that is in itself kind of difficult to comprehend at the moment, but it is actually quite an easy task. It's far easier than playing around with this. But both are right. Both of them hold dice numbers and the amount of rolls I've done. So if you can imagine that we got set, let's just take this out and put the 7th one in so that they match. Both of them contain 7 rolls that we did. However, this one is more efficient, far easier to play with, and this is where we're going. This is what we need to learn. We need to learn about arrays. Now, there are some rules about arrays. You've already seen one when we went over to the Python in W3 Schools, the tutorials and the reference manual, it says Python doesn't have a built-in support for arrays, but Python lists can be used instead. So actually what we're looking at here is not an array, it is actually a list. But we are going to treat it as an array. And I'm going to give you some of the differences between lists and between arrays that you can be confident when you're in your exam of how to deal with them. There will not be, and I repeat, there will not be any lists in the exam. As far as the exam board at GCSE is concerned, lists do not exist. You will not meet those until A level or degree level. Unfortunately, Python doesn't have a data type called array, so we have to simulate it using a list. And I'll tell you the differences in the next videos.